This naturalrefrigerants.com article is being read by an automated voice. ATMO Europe, Jaeggi's hybrid dry coolers to provide cooling for 12 megawatt CERN data center in Geneva, by J. O. Haraldson, published December 10th, 2025. Hybrid dry coolers manufactured by Swiss-based Jaeggi Hybrid Technology, a subsidiary of Guntner, will provide all of the cooling for a CERN, European Organization for Nuclear Research, data center in Geneva, Switzerland, with an installed IT power capacity of 12 megawatts. Ivan Hemmeler, Jaeggi's business development manager for Spain and Portugal, outlined the mechanical cooling-free system and its power usage effectiveness, PUE, in a presentation at the Atmosphere Europe Summit 2025. Atmosphere, publisher of naturalrefrigerants.com, hosted the event, which was held November 24th to 25th in Padua, Italy. PUE measures a data center's energy efficiency by comparing the facility's total power usage to that of the information technology equipment, including servers, storage, and networks. A PUE of 1 represents theoretical perfection, with no power used for cooling and infrastructure. By eliminating the chiller, we have removed the most energy-intensive component in traditional data center cooling, Hemmeler said, with the hybrid dry cooler system providing a PUE of equal to or less than 1.15. In addition, the technology uses 70% less water than conventional cooling towers, with just 0.379 liters, 0.1 gallon per kilowatt hour. The design, a water glycol loop, transports the data center's IT heat load directly to the hybrid dry coolers, where massive double-stacked heat exchangers reject it using ambient air for the majority of the year in Geneva's temperate climate. The design is so simple it becomes naturally resilient, Hemmeler said. In the event that temperatures rise to 40 degrees Celsius, 104 degrees Fahrenheit, during peak summer conditions, the heat exchanger coils are wetted, with the water fully recirculated. A cascade design saves water while boosting cooling power, with smart controls optimizing operation based on climate and demand, Hemmeler explained. Although the total system will be 12 megawatts, currently just 8 megawatts are installed. Of that, up to 4 megawatts, 1,137 tons of refrigeration, of waste heat can be recovered and supplied to nearby CERN buildings for space heating. CERN, Jaeggi, and Austrian refrigeration contractor Equans collaborated on the project. What's next? With the units now installed, the real learning starts as we assess system behavior and refine its operation, Hemmeler said. Removing glycol is the next step to simplify the design, Hemmeler explained, adding that doing so could increase efficiency by 10 to 20%. We've successfully operated glycol-free data centers with Jaeggi equipment for 15 years, he said. Recovering more waste heat from the system would also improve CERN's PUE, he noted. CERN and sustainability. CERN won the ATMO Europe 2025 Best in Sector Industrial End User Award for its use of a CO2-based refrigeration system to cool its new High Luminosity Large Hadron Collider (LHC) program, scheduled to start operating in 2030. CERN expects its new CO2 cooling system, providing a combined capacity of 1.3 megawatts, 370 tons of refrigeration, at its ATLAS and CMS particle detectors, to reduce its greenhouse gas emissions by 40,000 metric tons of CO2 per year compared to synthetic alternatives. Swedish-based manufacturer SWEB developed Q185H, a new CO2 brazed plate heat exchanger, for CERN's high luminosity program. It acts as an evaporator, absorbing and removing the increased thermal load from the higher radiation levels. Quotable: "The right mindset unlocks solutions that technology alone cannot achieve," Hemmeler said. "This isn't just an incredible improvement, it's a fundamental reimagining of what's possible. Thanks to CERN's willingness to challenge the standard chiller-based cooling for data centers, we replaced mechanical cooling with only air and a little bit of water.